What you're hoping for. We're not. All right. Surface area. How much icing do we need? Is it track that day? No. Oh. But we can look at some older footage. Anyways, we're gonna start. And so sine waves. I'm sure you've heard of sine waves before, right? If not, then maybe this will be the first time. But yeah, if you were to graph a sine wave, you might wonder, what about cosine? What about tangent? We only focus on sine, right? Because but all of the trig functions would have a wave like this, and they are cyclical, meaning they repeat, right? You go up, you go back down, it would repeat over and over indefinitely. Okay, so you kind of have a bit of a boundary on the range, but you don't have a boundary on your domain, right? So I thought I'd put that right on the cover. So let's go to page 2. I would encourage you to have 2 to 3 or 4 colors of highlighters, especially for what I'm about to give you in terms of information. I'm going to have mine ready to go here. Yeah, this one is going to be, I like highlighters because this is new. You haven't seen this stuff before, okay? So first and foremost, before we get going, okay, and this is very important for you to get everything right. Change calculator to what? To radians, okay? And you might not know what radians are right now, but that's beside the point. We're going to turn on our calculators, and at the top of your calculator, you should be seeing radian. If it's not in radian, your graph will be completely different. So we're going to go to mode. You're going to press mode and just make sure you go all the way right there, the 4th line from the top. If it's set to degrees, right, if that's highlighted, just go to radians, hit enter, and you're good to go. Okay, so that's step number 1 before we continue. What is a radian? So if this is a little bit confusing, don't worry about it too much. We're just going to stick with radians, okay? The textbook uses degrees, so I don't really use the textbook, okay? I have my own stuff. The province just does, we do radians, and in pre-cal you do radians as well, okay? So radian is an alternative way to express an angle, okay? Using radians allows you to express the measure of an angle as a real number without units, right? So you basically talk about an angle without units, so no degrees. The central angle formed by one complete revolution in a circle is 360, or 2 pi in radian measure, okay? You're like, what's going on here? So I will try to give you the Cole's notes here, like the shortest version possible. This is what a radian is. If you were to take the radius of a circle, right? You were to take that and then spread it out and over this arc on the outside. Like when you have the radius of the circle spread out on the outside like this, as if you were to lay it out around, right? That angle that is formed by doing that is called, that's what we call a radian, okay? That's what we call a radian. So if you take the radius, right, and then you say, okay, I'm going to spread it out over here, and wherever it ends, right, there's an angle formed. That is a radian, 1 radian, okay? And it turns out that it's always consistent, okay? And then pre-cal, you would probably memorize, if you ever are going to take it, the unit circle. I don't know if you've ever seen that, but we won't worry about it because we use the calculator for that, right? So I just need you to know, if you look at the coordinate plane, this would be 0 pi. If you start here and you turn all the way around, we consider that 360 degrees, right? So we would say 360 degrees. 0 when you start, but when you go all the way around is 360. And I'm not going to spend a whole lot of time. So it's 0 or 2 pi. Sorry. If you talk radians. If you talk degrees, so we can talk about the same thing on if you make a circle, you're talking, there is a correlation between the two. Okay, there is a correlation between the two. And that's all I'm going to say. Well, maybe I will say that if 2 pi is 2 all the way around, then from here to here would be what? 180 degrees? Or how many pi's? If it's 2 pi's all the way around, then it's just pi to there. Okay? So you have a bit of a... So instead of saying, hey, I want an angle of 180 degrees, you can also just say, I want an angle with pi radians. Different way of talking about it, but that's what radians would represent. So that's all I'm going to say about it. We're sticking with radians, and that's that. Okay. If you want more information, look up a YouTube video on radians, but we don't require that much in-depth knowledge of that. So, but really what it is, one more time, if you take any tire, if you take any tire and you measure, hey, from here to here, let's say it's 4 inches. Let's say it's 4 inches. You take this and you start here and lay out the 4 inches across here on the outside, right? And then you say, okay, now I'm going to go from here to there. That is a radian. Okay, that is a radian. So that's what a radian is. Okay, keep going now, okay? Enough of radians. But in the math world, we usually use radians. And you can convert. You can convert from degrees to radians, but we're not going to do that. Everybody have the booklet, right? If not, I have 2 more here. So make sure you get it. So we're going to learn today how to graph and also how to extract information from a graph, as well as we do a regression, sinusoidal regression, so that you can accuse me of not telling you how to do a sinusoidal regression. Should it ever be the case, you just go stat, calc, and if you go all the way, it's actually easier to go up the list. But if you go all the way, sine reg right there. Okay, that's that. When you do a regression, you do it the same way we use sine regression. There's no cosine regression, so don't worry about it. Okay. Right, alpha C would do the exact same thing. Yeah. Actually, I go stat, calc, I go up, and there it is, up 3 times, or alpha C, whatever you want to do. Yeah. Okay. So here we go. I just have my graph in front of me. Okay. I tell you stop, change from degrees to radians, right? That's very important. If not, you're going to be frustrated. When we deal with data that appears to have a repeating pattern, so if you have a repeating pattern on regular intervals or cycles, we need to use periodic functions. Right? Period, the time it takes for a full cycle to complete. The time it takes for a full cycle to complete. That's important to understand. It can be determined in several ways. It depends on the information you're provided. And this is very important. Stated as a positive value. Right? It's always going to be a positive value, regardless of what you get as a calculation. Usually it is a positive. A sinusoidal function, any periodic function whose graph has the same shape as that of y is equal to sine. This is the most simplest form of the sine wave, which you're never really going to see. It's always going to be, there's going to be more stuff around it, as you can tell, right? You can tell here that there's more stuff around it. Midline is also known as the median. You need to make sure you understand that. And I don't know if you remember median. Do you remember median from stats in grade 11 applied? half of the values are above, half of the values are below, and that's what median is. The horizontal line halfway between, right? The line halfway between the maximum and minimum. That's what that is. The maximum is the highest value the wave achieves. The minimum is the lowest value the wave achieves. One thing I need to warn you, we quite often just refer to them as the Y values, okay? The highest, can we do this? Just insert a Y there, the highest Y value and the lowest Y value the wave achieves. And that makes sense, right? Max, min, I don't need to highlight anything there. The amplitude is the distance from either the midline to the maximum or the midline to the minimum. It's always positive as well. No matter what you do, the amplitude is always going to be stated as a positive for us. Let's just do a quick sketch of a sine wave, just like that. And try to find a line that represents the midline. Okay? So this is the mid. Okay? So the amplitude would always be from the mid to the top or from the mid to the min, right? That's what we call the amplitude. I'll just put a lowercase a there for you to know what it is. In general, a sinusoidal function looks like this. That's what it looks like. And A is the amplitude, right? Affects the max and the min, right? B affects the cycle or the period. Basically, how often does it repeat, right? How often does it repeat? C affects the horizontal shift, so it'll move the wave sideways. And D affects the vertical shift. It is the midline or the median. And before I'm going to add more to this, but please just look up for Desmos presentation. Okay, I just find it a little bit easier to visualize something that's static. So if I were to change the A value here, A, right? Just notice what happens to it as it gets smaller. The wave is also, right? The min and the max come closer together because it measures the distance, and the midline is in dashed, right? It's that dashed line. So the distance is smaller, or if I increase it, right, it makes the max higher and the min lower. That's what the amplitude does, right? It extends the distance between the midline and the tips, right? So that's one attribute here. So the amplitude. B right there affects the period. So watch this. The bigger B gets, the quicker the repetition, the quicker it will repeat itself, right? Because think about it, from here to here, from 0 to 2, right? It's like it's 2. It takes 2 horizontal units for it to repeat itself. If you increase it even more, right? Look at from here to here, it's 1.39, right? So it actually happens more often. The bigger B gets, the closer together this will become, and so the faster it happens. So B affects the cycle, right? At the smaller B gets, the longer it takes to repeat. If B gets larger, it actually happens much quicker. Okay. So, and then C, what does C do? It's almost like a heartbeat, right? Beep, beep, right? Anyway, so this is C, that's what C does. We're not really concerned with C a whole lot. A, B, and D is going to be our focus. D, what does D? It's actually the midline, but it actually will shift the whole thing up and down. That's what D Yeah, so it tells us what the midline is. Can I just say something? It is not the y-intercept. Are you listening? It's not the y-intercept because we're so used to that constant at the end is our y-intercept, right? With all the functions, or the polynomials in particular, it's not the y-intercept, okay? So that's my Desmos presentation to you. I hope that helps. And now I'm going to fill that in, that box there a little bit, because I like you to be able to look at this and quickly review it, right? So amplitude, if A is greater, so go A arrow up, right? If this is your midline, it's going to look like this, right? Like it's going to be a bigger difference. If A is decreased, I was able to fit this in, and just make sure it's like a little bit of a shallower, right? The min and the max are going to be closer to the midline. Okay, what happens when you change B? If B is greater, okay, I'm going to ask you questions about this. What would happen if I increase B, right? So this will quickly review that for you. If you increase B, it looks like this. If you decrease B, it looks like this. Right? It's more spread out. Affects the horizontal shift. I really don't think this is too important, but I will give you what it does. So I do one curve like this, and then I use a different color and just tell you, hey, if you change it, it shifts it. Right? It shifts. So everything gets moved either right or left. It depends on what you're doing. And D affects the vertical shift or the midline, right? So watch what I'm going to do here. Follow me here. This is my midline. I'm going to graph one like this. And I'm going to use a different color and just make one right on top of it like this. It's the same curve, but we will have changed something. What happens to D when that happens? When everything raises, D is increased. Okay? And if you go lower, my blue pen is here. If you decrease D, obviously you're going to have one that is lower, right? So that's somewhere in there, go D is being decreased. It will drop, the whole thing will drop. So yes, it affects your midline, but it actually also affects the whole graph, not just the midline. Can I add that here? Bless you. Shifts, wave, up or down. Okay. So yes, Mr. Dirksen, you should have made that box bigger. I get it. But you got to understand, I am rushing to make these booklets, and sometimes it just kicks in a bit later. So if you want to retake this course again, I promise you next time around it'll be better. You don't want to take this again, do you? Anyways, formulas, okay? So I have to tell you this. These formulas are a bit crazy. I give you too much, more than what you probably need. Because yes, there are several ways at arriving with an answer. So I'm going to box in the most popular ones, okay? So if you're asked to find the period, take x max 2 minus x max 1. And right now that means nothing to you, and that's okay. But I will say this is for me the most popular equation, the formula. This one works as well. This one works as well, okay? Or this one. So I will box this in. This one is important as well. Use when equation is given, okay? This last one, you want to only use that one when the equation is given. That's going to be our default. When the equation is given, that's what we're going to use the most. Amplitude, you can go y max minus the middle, or you can go y max minus y min divided by 2, or just get a from the equation. That's also popular, but this is by far the most commonly used by me, the middle equation. The midline is you basically are finding the average between the highest and the lowest point, right? Y max plus y min divided by 2. Can I just say something? It's very similar to amplitude. Very similar. What's the only difference between them? Minus plus. Please get that right. You got to get that right because you get the complete different answer. It'll throw everything off. Notice that I will highlight when the equation is given. You would just do this, right? When the equation is given, I would just use that. I wouldn't use the formula. I would just use this. And then your domain and range. What do you think the domain is going to be? All real numbers. Or negative infinity to positive infinity. So set notation, interval notation. The range will be y min greater than or equal to, so that's the y variable we're interested in, all the way up to the y max. That set notation or interval would just be y min, y max. And I'm telling you, you want to spend time, when I assign you how to graph these things, you want to spend time and practice on your own. You want to be very proficient at it. You want to be good at it, okay? These things are all going to come into practice if you graph. You're going to use this a lot, right? Right now, they're just formulas. They don't mean much to you, but if you practice, I promise you're going to get a pretty good handle on it. You will only learn math by doing math. All right, let's go over to page 4. So let me try to tell you what I wanted to do with this. This equation represents that graph. But for a moment, we're going to ignore this. We're going to pretend like we don't know what the equation is. I'm just going to give you a graph. And I'm going to ask you to answer all these things down here about that graph. Okay? So let's label some of the things on this graph to begin with. In this particular snapshot, there's 1, 2, 3 maxes, correct? Always focus on 2 consecutive maxes. I know it's not really a word, I'm just making stuff up, right? But I'm going to focus on these 2. So this is a max, and this is a max right here. Okay. Max, max. And what I do is I tell you that this would be x max, comma y max. So a maximum, that's a point, and I refer to the x variable as x max, y variable as y max. Can you put a 1, like a sub 1? Why is that, Mr. Erickson? Because right next door we have another one. That's x max 2, y max 2. So yes, 2 maxes. Mr. Erickson, could I have used these 2? Yes. The answer is yes. But why do you think I'm not going to use this one? Because there's some negative values there. So I'd rather stick with this if I have the choice. Okay, so here we go. How would I find the period based on this? Remember, and here's where your highlighters are going to come in handy. What is the period? It is basically how long it takes for something to repeat. So it is actually the distance, the horizontal distance from here to there. That is the period right there. And so the period, for me, I'm going to use period is I'm going to go here, okay? Because I already did this before you. So period, I'm going to use this formula, x max 2 minus x max 1. And x max 2 is what? 10, right? 10.001 minus x max 1 is 2 exactly. So the period is 8.001. For all intents and purposes, 8 units, right? If you round it to 2 decimals, it would be 8. Could you verify that? Sure, right? Just count. 1, 2, 3, 4, 5, 6, 7, 8. Okay? There's another way of doing this. You need to know this, okay? There's a min here, and there's another min there. You can focus on the two minimums, two consecutive minimums. So this would be x min 1, y min 1. This is x min 2, y min 2. Right? So you can technically just subtract. Remember, the period is the horizontal distance, right? No y value should be used to figure out the period, okay? So x min 2 minus x min 1, that would be x min 2 is 6 minus, what is x min 1? -2. So you gotta watch out. It's minus, like this minus is the difference, and it happens to be a negative value. So that's really 6, negative and negative is plus, right? So it's 8 units. So you still get the same. I just want to show you that it is the same. A bit repetitive. But you understand what I'm doing, right? Period is the horizontal distance. If x is time, then it would be the time. If x is distance, then it would be the horizontal distance for something to repeat itself. One more, guys. You need to know how to do this. The other formula says that it's 2 times x max minus x min. This is the one that's a bit more confusing, but if you really think about it, you should be able to understand. Let me just brighten this up a bit. Brighten up your day. 2. So, would you agree with me? Look up on the screen for a little bit. To go from here down to here, that would be half of a period, correct? You see that? So if you only get this and this, if you subtract the x values, right, you're going to get half of a period. That's why you need to multiply that by 2 if it ever happens. So I'm going to go x max is 2 minus x min is 6, right, like that. And that is 2 times negative 4. Period is negative 8. But remember, I told you always state it as a positive, right? I told you that earlier. If not, you did highlight it. Period is 8. It's always positive. So even if your calculation tells you is negative, make sure you state it as a positive. So every 8 units, this thing will repeat itself. Okay. Next, using the equation. If you don't have the graph, guys, you can't really. I wouldn't use this. If I give you this equation straight, right? You would use this formula. Period is equal to 2 pi divided by b. What's b in the equation right now? What? B. Remember, this is what it looks like in general. Sine bx plus c plus d. So b is always right attached to x, correct? Mr. Dirksen, what happened to c in the brackets? What's c equal to right now? No. C is equal to 0, okay? Just making that note, right? It can be 0. But anyways, this is b. This is what we're going to use. That's the b value. So we're going to go over here and just go exactly the way I have it there. And I will actually encourage you to use up to 4 decimals. So go ahead and use your calculator. What are we expecting our period to be? 8, right? 2 pi. How do you access pi? You should know that from designer measurement, but second hat, right? And then you divide it by 0.7853. And that is 8.001. For all intents and purposes, our period is 8 units. It all jives. Many ways to get there. Most popular, second popular. No, actually, I would say these two are the most popular, right? If I have a graph, I'll use this. If I have the equation, I use that. These are alternate methods. All right, moving on. What's amplitude? Amplitude, let's just put down 8 units here. 8, right? We figured out that from low to low or from high to high, it's 8. Right? If you want to put 8 down, period is 8 right there. So you have that figured out. Amplitude. I'm going to go orange here. And you should know that amplitude is from the middle to the top or from the middle to the bottom. Do you have the middle visible here? Yeah, Mr. Dirksen, is the x-axis, obviously. Does it look like it's the middle? It doesn't. This is definitely not the middle, right? So I actually should have put midline first here. So I'm going to skip that for now. Let's figure out our midline. And I'm going to use blue for that. What's midline? Midline is also known as D, and it is the Y max plus Y min divided by 2. That's what that is. Okay. So for D, what's the Y max? What's the Y max? Does it matter which one we pick, Mr. Dirksen? The Y max is 7, is 7, is 7. It doesn't matter. It's always at the top, right? So we're going to go 7 plus, what's the min? It's always -3, right? -3, -3. So you name it, it's -3. Divided by 2. 7 plus -3 gives you 4. 4 divided by 2 is 2. So the equation of the midline is y is equal to 2. Okay, that's the equation of the midline if I ever ask you for it. You do the math and then you figure out that y is equal to 2. And you're like, what about D, Mr. Dirksen? Well, D is on the equation, that's what it is. Does that surprise us that it's 2? Look at it, jives. We knew this already. So I'm kind of trying to get you to see that if you use the graph to come up with stuff, it should jive with the equation that produced it. So I'm going to take my blue highlighter and just go along the 2 here. I'm going to make a dashed line. Y is equal to 2. And so that's my midline. So the amplitude goes from the top straight to the middle, or from the middle to the bottom, right? That's your amplitude right there. Stays the same, right? Now you know why I highlight, right? So amplitude is actually the A is going to be y max minus y min. Oh, is it minus? Is it plus? What is it? Study sheet right there. It's minus divided by 2. Y max is 7 minus, what's the y min? It's -3. And we divide that by 2. That is 7 plus 3, correct? That's 10 divided by 2, which is 5. Amplitude is equal to 5 units. So I'm going to highlight that orange as well. We figured that out. Does that surprise us that A is 5? You could have, there's many ways to verify it. You count how many units it takes, and it is 5 here. You can look at the equation. Where is A situated? Right? A is 5. So highlight that orange as well. And whatever highlighter you use for your midline, highlight that over here. Those two pieces, if you have the equation, boom, you know right away 2 things off the graph without even calculating anything. A lot of information, I know. But you can do it. And I will highlight all the periods with the same highlighter I used for the horizontal distance. Your period is the only one that involves the x values. Everything else so far has involved the y values, right? I will also go down to the midline here. And can I just say, also, d is equal to 2, right? It's the same thing. D on the equation, on the graph, it would be the line y is equal to 2. Right? Domain and range, I'm just going to do the x is part of all real numbers. And the range, I like this one. Smallest and greatest. I like the interval notation, especially with this. You find your min, you find your max, right? This is the y min, and this is your y max. Quite often, guys, 95% of the time, the questions will not talk about y min or y max, just min and max. Because most of the time it's the y value. However, students mix that up and find the period using the min and the max, right? So you gotta watch out. It's the x min, x max for the period because it's a horizontal distance. Okay, let's keep going. I want a graph. That's what I really want to do, and I'm not sure if it's going to work out for us, so maybe I'll have to do it tomorrow. So let's go to page 5. I'm just thinking a little bit here. If I skip this and go straight to graphing, it might bite me because I went too fast. So I'll do this first. Okay. Question 5. Sinusoidal regressions. To perform a sinusoidal regression, you need to determine how many points? You need to make sure you understand it's 5, or else you're gonna be in trouble. Okay, it's gonna give you an error. You need 5. Okay. And so before we do that, I'm gonna ask you we're gonna fill in the characteristics chart. Characteristics is anything we can tell about the wave without graphing it, or by just looking at the graph and then deducting it. So let's go ahead and figure out this chart here. And what I'm going to do here is I'm going to identify two max points right here. So put a little dot there and there. Those are two consecutive maxes. So what is the coordinate of this point right here? This is -5, and you can do this if you want. I'm going to do that for you. I'm going to actually grab my ruler. I'm going to do this a lot later on as well. I'm going to dash the top. I'm going to dash the bottom. That way you see, okay, that's like the min and the max. So the coordinate of this point is -5, -13. And the coordinates of this point would be 11, -13. And I'm just going to focus on that for, actually I'm going to find one more, this one in between. So I find the two consecutives and the valley is usually a good one. So the coordinates of this one is 3, negative what? -27, right? And I picked weird numbers on purpose, like negatives, ugly stuff like that, so that we have to deal with it. If you could put arrowheads on this wave, that'd be great. All right. So let's find the max. And in particular, I'm going to ask you to add the equation of the max, the equation of the minimum, the equation of the midline. So the first three should have equation on them. And I'm going to zoom out a little bit so that I make sure to put that on there. The formula, if you wanted this, you would just say y is equal to y max. Okay, so y max is equal to -13 units. And for the minimum, obviously, it's going to be y min. So the equation of the min is -27. The midline, I would strongly encourage you to say y max plus y min divided by 2. And so the y max is -13 plus -27 over 2. And that is -40 over 2, which is -20. Let's go ahead and I'm going to use blue again. But this -20 here is my midline. And I'm going to go and graph that. I'm just using a dashed line for that. If you just have a pencil, that's fine. But that is the equation, y is equal to -20, which is also known as the midline. And you can tell, you should be able to tell that it is halfway. Half of the values of the curve are going to be above it, half below, right? Within a cycle. Amplitude, it's going to be y max minus y min. I put them next to each other so you could see that, right? So it would be same thing as above, except for you have a minus, a double negative there. And that will actually give you 14 divided by 2, which is 7 units. And I'm going to use orange for that. I have a better orange highlighter here. I like this one more, it sticks out. So the 7 is there. And so the 7 represents this, right? Straight to the max. Okay, so you should be able to verify that by counting, right? 2, 4, 6, and another one that's 7. So there's your amplitude. Period. You got to shift gears here. It's x max 2 minus x max 1. And no divided by 2 here, okay? It's just a difference. But Mr. Jason, can't you use min and min? Yes, you can. All right, I'm just using 1 so we don't lose it completely, right? And really, it doesn't matter which one you make your 1 or your 2, as long as your final answer is positive, right? So I'm going to make this my 2 and this my 1. x2 minus x1. So x2 minus x1. And that's 11 plus 11 plus 5, which is 16. 16 units. And you should be able to verify that. I'm going to use green for, I used yellow earlier. Be consistent, right? So I'm going to use yellow. So I'm going to go up to my graph. And what did I just find? Not anything with y, it has everything to do with x. So it's like the horizontal distance from there to there. And you should be able to count. I did count, it's 16, right? So 16 units. Remember, you could transfer that highlighted portion onto your x-axis, right, up there, and just count along the x-axis. Domain, easy. And this is what I'm doing here. I'm just using both cells because there's no formula really. And the range, I'm going to give you this one, y min to y max. And so it would be negative 27 to negative 13. Highlighters help, right? I don't know, if you looked at this page without highlighting, it would be different, right? To me, it changes everything to see it right away if you flip to this page, right? And if you want to go all out, you can find 2 different highlighters and actually highlight the top and the bottom as well if you want. That's up to you. Okay. Now the equation. How would you come up with the equation? Well, you need 5 points. And I'm going to do this up here on the left here. So come with me for a bit. Join me for the ride. I will already foreshadow something for you that's going to come down the pipe, okay? What we focus on is if you start at a max, the next point we focus on that curve is something on the mid. The next point we focus on is on the min, which you already have. Then the next point we focus on is back on the mid, and then back to the max. How many points did I just go through? 1, 2, 3, 4, 5. Why do you think sine needs 5 points? This actually completed a full cycle. Did you notice that, right? We went from the max back to the max. So sine needs a full, like 5 points to kind of make out a cycle out of that, okay? So that's why it's the points. We're going to read right off of this graph. What's the point right here? This is -1, -20. We already have our min, so good. Then we go over to here. What is that? You need to help me out with that. I think that's 5, 6, 7. and we still have negative 20, right? So we have 1, 2, 3, 4, 5 points. Please come with me on the side here, and I'm going to write them out. X, Y, negative 5, negative 13, negative 1, negative 20, 3, negative 27. So I'm just copying these points out. 7, negative 20, and 11, negative 13. Then you're going to go stat, calc, sine, reg. You don't have to tell me the L1 and the L2 part. That's fine. Okay. So let's go ahead and do that. See if we can reenact this. So stat, calc, no, not calc, edit. And first I'm going to enter all these points into my spreadsheet. And I'm just going to take a moment to double check. If you get an error, you probably got a small, tiny little mistake and it can't do it, right? So you got to watch out for that. And then it's stat, calc. I'm going to go up arrow, find sine reg. Second one, second two, comma, alpha trace is the new way to do it. If you're comfortable with how we used to do it, just keep it that way. And run your regression, write it down before you do anything else. I was going to go arrow down here, all the way down. And I'm just going to write it in here. Y is equal to 7 sine. Watch, I'm reading it off of my, right, sine. Can you please make sure you put at least 4 decimals into B? And I will explain more later why that's important. The rest I don't really care about. Minus 20. So sorry there. That's the equation that I got. That's the equation. This doesn't surprise us, right? That's our midline. This doesn't surprise us, right? We knew that it was 7. Amplitude is 7. You want to check if you got this right? How would we get our period out of that? 2 pi divided by 0.3927, right? What am I supposed to get? 16. Very close. Right? Very close. So there's a way to double check. So if your head is spinning right now, that's normal. My head spins after teaching this. Never mind yours. But you're smart. I know you're going to overcome this. I'm going to skip this one because it's doing the same thing except for you have no graph. But trust me, you can fill all of this in a lot quicker. You have everything you need right up there. So I'm going to skip this for now. No, I'm not going to skip it. I know what's going to happen. It's going to backfire. I'm going to show you graphing tomorrow, okay? So come in and enjoy the show tomorrow. First thing you want to do here, is make sure you understand that that's A, that is B, that is C, and that is D, right? You got to understand that. Sometimes C is missing, sometimes D is missing, but it's not really missing, it's just 0, okay? A and B cannot be 0. Because if A is 0, the whole thing, right? Like it's not going to be a sine wave. And if B is 0, you have no x, right? So it's not going to be a graph, okay? Remember, I will remember. This is a big note. There are several ways to determine the characteristics. Okay, very important. If you see me do it a certain way and you're like, wait a minute, I know a different way, then go with it. That's fine, because I did show you that there are several ways of doing it. So some students get stuck with the fact that they look at my key and say, oh, how come you did it that way? Because that's just how I chose to do it, right? So no graph, right? Just equation. That's all you have. How would you do a characteristics chart? And you can expect something as early as tomorrow on this, right? AC. So how would we fill this in? Maximum. Watch this, guys. Um, can we do equation? Just write down equation. Equation. I just don't want you to that to throw you off if I asked you determine the equation of the max or the equation of the min. It's not, it shouldn't throw you off. So basically what you're finding is the y max. And watch this. It's d plus a. The y min is d minus a. The midline, it would just be y is equal to d, correct? If the equation is given. Done. The amplitude is just a is equal to a value of equation. I don't know. There is no formula really. It's just as simple as that. Period. You would use this one. Domain and range, same as before. I just want to make sure, does this make sense to you that the y max would be d plus a? Would that make sense to you? I need you to understand, like if this is d, right, and this is a, right, this point up here, right, the highest point would be d plus a, and the lowest point would be d minus a. Would that make sense to you if I do it like this? D plus a, d minus a. So boom, right there. So Jason, can I just graph it and then use my calculator to find it? Yes, that takes longer, right? It takes longer. So we're going to say y is equal to, what's d over there? Minus 7 plus 15. And that is 8 units. Why are we putting units? Because soon it's going to be seconds. Soon it's going to be feet, right? So you know where we're going, right? And then y is equal to d, which is negative 7, minus a. And that's negative 22. Negative 22. So this goes as low as negative 22 and as high as 8, right? So this is our range right here, guys. The midline, y is equal to negative 7. Okay. A is just 15 units. Could be that the average temperature, right, for a certain, if you go for Manitoba, it might be negative 7, right? So 7 is kind of like, not really. I think it would be higher than that, but and then the period would be 2 pi divided by, what's b in that case? 0.1257. That's 49.99. There you need to, it doesn't round to a whole number there. I will, quite often it will be the case, but not always. The domain is just all real numbers. How about we use set notation here and we use interval notation on the right side. Range would be negative 22 y negative 7. Sorry, not right. This is 8, right? My max is 8. So this is 8. Squiggly brackets, or my preferred way of stating the range is using interval notation, right? So it's between -2 and 8, and that is that. So no graphing, no graphing. So I'm gonna see here pages 9 and 10, guys. We do this kind of stuff. I'm just going to say something. Some of you are writing this down still. I want to give you a little bit of a, I'm going to expect you to be able to come up with the equation tomorrow. How many points do you need? How many finger in one hand? Try to figure ways, right? You go like this, 5, right? I don't know. And so page 9 has 2 graphs, and I'm asking you to fill all of this in for both of them, and notice that at the very end, equation. I have that on the key. I will post it soon. And you focus, if you can, focus on max, mid, and min points, right? So graph your midline there, and then you will go, right? You will start here. You will take these 2 for sure, and you will take the min, right? And then there'll be 2 points on the midline. So 1, 2, 3, 4, 5. That's what 5 consecutive points will do the trick for you. What's that? Sure. Yeah. And if you have any questions, you know how to reach me.